Well, students, let us move towards the other learning point, that is distance and displacement in linear motion. Well, students, we have learned about the linear motion, that is, if an object moves in a straight line, then the motion of the object is said to be linear. So, I am showing you this particular picture which is there in your NCERT textbook. So, here I am showing you the position of an object which moves on a straight line from a fixed reference point O. I have already explained you about the reference point. Here the fixed reference point is O. From that point O, the object is moving. So, see the observations. The observations are like this: A, B and C are three different positions. See, on the right hand side you see the position A is mentioned, and in between O and A, so two positions are mentioned, B and C. That's what it is. The observations A, B and C are three different positions of an object in a straight line at different instant of time, because the object is in motion. It starts from the reference point O, moves at point A, then comes back, reach at point B, then comes back, reach at point C, then comes back, reach at point O. Well, so what would be your second observation? At first, let the object reach at A directly. Then the object moves back along the same path and reach at B, then at C respectively. Then from this picture, I wanted to ask you this particular question. Please see this question. So, what is the total path length covered by an object when it moves from O to A and back to C along the same path? Once again I am showing the picture. It directly goes to A from the reference point O, then it comes back to C in the same path. Now you see the question. What is the total path length covered by the object in this situation? Well, so I have mentioned the total path length or the distance covered by the object when moves from O to A and back to C is equal to OA, because at first it started from O, reach at point A, plus because it is coming back to position C in the same path, plus AC. So, OA plus AC is the total path length or distance covered by the object as it moves from O to A and back to C. OA distance is equal to 60 km. See this picture. Each unit I have divided into 5 km. O to A, you see this is 60 km. Then A to C, you see. So, it is 35 kilometers. So, OA is equal to 60 km. AC is equal to 35 km. That's a total path length or distance covered by the object is equal to OA plus AC is equal to 60 km plus 35 km is equal to 95 km. So, distance covered by the object is 95 km. Well, let us define the term distance now. It is the actual path length covered by an object irrespective of the direction of the motion of the object. The path length, whatever the object covered, may be in north direction, may be in south direction, may be in east direction, may be in west direction. Irrespective of the direction of motion of the object, the actual path length covered by the object is known as distance. So, this is the definition of distance. Well, I am just asking one more questions from the same example which is given in your NCERT textbook. So, what is the shortest distance covered by the object from the initial position O to the final position C? I am just showing you the video clip once again. So, here the initial point is O, the final point is C. So, these are the two positions, initial position and final position of the object, because the object is in motion. Now, I am asking the question, what is the shortest distance covered by the object from the initial position O to the final position C? The shortest distance from O to C, definitely it would be equal to OC. Am I right? So, what is the distance between O and C, that is OC is equal to 25 kilometer. So it is well mentioned in the picture. So the distance with direction is known as displacement. Here I am using the term direction because the distance covered by the object from the initial position O to the final position C. So that direction is from O to C. That's why the distance with direction is known as displacement. So here OC is the displacement of the object with the shortest path length covered by the object. Well, so let us define the term displacement. So what is displacement? It is the shortest path length covered by an object from its initial position to the final position. Well, after understanding about distance and displacement, what is the unit of distance and displacement? Do you know, students, the unit of distance and displacement is the same, but the SI unit is meter, represented by the symbol small m. CGS unit is centimeter, represented by the symbol small c small m. Of course, the bigger unit we know, that is kilometer. And all of us know that 1 kilometer is equal to 1000 meter. Am I right, students? Well, thank you. Then let us switch over towards the difference between distance and displacement. Both are the distance, but the actual path length is the distance, but the shortest path length from the initial position to the final position is the displacement. Then what is the difference between distance and displacement? It is in front of you, you see. Distance is the actual path length in any direction, but displacement, I am just putting it in the right hand side, displacement is the shortest path length in a given direction. Then distance is described by its magnitude only, 10 meter, 12 meter, 15 meter. So distance is described only by its magnitude, but displacement is described by both of its magnitude and direction. 10 kilometer in the north direction, 15 kilometer in the east direction, 20 kilometers in northeast direction. So magnitude with direction will give rise to displacement. Distance is a scalar quantity because it is described by its magnitude only, that's why it is a scalar quantity. While displacement is a vector quantity because this vector quantity can be described both by its magnitude and direction. Since displacement can be described by both magnitude and direction, that's why it is a vector quantity. How do you denote these quantities? Distance can be denoted by the symbol s, simple s. But on the other hand, displacement could be denoted by the same symbol s, but you see an arrow mark on the top of the letter s. So if you will find an arrow mark on the top of the letter, then that will indicate the physical quantity definitely must be a vector quantity. Then distance is always greater than or equal to its displacement. Of course, I will come to this particular kind of conclusion later on. On the right side, I have mentioned displacement is less than or equal to its distance. So this is the basic difference between distance and displacement. Well, I am just coming back to the same figure as given in the NCERT textbook, that is position of the object is changing. That means the object moves on a straight line from a fixed reference point O. Now my question is, what is the distance and displacement if the object moves from O to A directly? See the picture. On the left side, the reference point O is there. Object started from the reference point O and reach at point A directly on the right hand side. So what is the distance displacement of the object in this situation? Well, see, in this case, the distance, as I mentioned, denoted by the symbol s is equal to OA. It is there in the figure. OA distance is equal to 60 kilometer. That's why it is S equal to OA equal to 60 kilometer. And the displacement is again S, but arrow mark is there on the top of the letter S, equal to 60 kilometer, but distance with direction is called the displacement. That's a 60 kilometer. What is the direction? Direction is from O to A. O is the initial position, A is the final position of the object, then the direction is from O to A, initial position to the final position. Hence, see, distance S is just equal to the displacement. S, magnitude of course I have seen, magnitude of displacement I have shown in this, cliff equal to 60 kilometer. In this case, distance is equal to displacement. Then I am again showing the same video clip. So in this video clip, I am just asking one more question. So what is that question? What is the distance and displacement of the object if it moves from O to A and back to B along the same path? Again, you see, it moves from O to A and back to B. So what would be its answer? The distance is certainly S equal to OA plus AB, because the object moves from O to B. First of all, it reaches at O, then comes back to B. So S is equal to distance equal to OA plus AB. OA is equal to 60 kilometer. AB is equal to 25 kilometer. So the distance S equal to OA plus AB equal to 60 kilometer plus 25 kilometer equal to 85 kilometer. So the distance covered equal to 85 kilometer. Then what is the displacement in this case? So displacement is the shortest path length between the initial position to the final position of the object. So the shortest path length S, arrow mark is there on the top of the letter S, you see this, equal to 35 kilometer from O to B. See this picture. So what is the distance between O to B? See, at the initial position it is 0, then at the final position means B, I am saying B is the final position, mentioned 35, below B it is mentioned 35. That means the position B is 35 kilometers away from position O. That's why OB is equal to 35 kilometers. So the shortest path length between O and B is 35 kilometers, which is the displacement of the object. So then see this video clip once again. Same video clip, position of an object in which the object moves on a straight line from a fixed reference point to O. Now the question is, what is the distance and displacement if the object moves from O to A and back to O in the same path? I am repeating the questions. O to A and again back to O on the same path. Then what would be the distance and displacement? You know, distance is denoted by the symbol S. S equal to OA. First of all, it moves from O to A. Then from A, it moves to O. OA plus AO equal to S equal to 60 kilometer plus 60 kilometer equal to 120 kilometer. So distance S is equal to 120 kilometer. Then what is the displacement? Can you tell me the displacement in these situations? Now initial position coincides with the final position. Then the displacement is 0. That's why I mentioned displacement S, arrow mark is there on the top of the letter S, is 0. The magnitude of displacement is 0 as the initial position of the object coincides with the final position of the object. Well, so let us discuss about the application of these concepts with the help of the following questions. See the first questions. Your friend Usha runs continuously around a 200-meter circular track twice. The track is circular and the circular track, 200-meter circular track is there. Then the question is, what is the distance covered and displacement of Usha in this situation? I am just showing this video clip. This is the circular track. Usha is running on this 200-meter circular track twice. That's why you have to find out the distance and displacement of Usha whenever she completes 2 rounds in this circular track. So what will be the distance covered by USA? Since it is 2 rounds, one round means circumference of that circular track equal to 200 meter. 2 rounds, twice she has completed. So 2 rounds means 200 meter plus 200 meter equal to 400 meter. Distance covered by USA equal to 400 meter. But what is the displacement? Again, the initial position of USA coincides with the final position because it's a circular track. The point where she started, at the same point she is reached. That's why the displacement of USA is 0, as because initial position coincides with the final position. Then you see the second question. In the above question, I am just repeating the same question. USA is taking the run continuously around a 200 meter circular track. This is the situation. In this situation, I am just saying in the same question, find the distance and displacement of USA if she runs continuously for 1.5 times around that circular track. Not 2 times, it is 1.5 times. So what would be the distance and displacement of USA? Distance covered, it is 1.5, 1 complete round, circumference of that circular track 200 meter, then half round of that, circumference equal to 100 meter. So 200 meter plus 100 meter equal to distance covered equal to 300 meter. Now, what is the displacement of USA? Obviously, we know the definition of displacement. It is the shortest path length between the initial position to the final position of the object in motion. Now, whenever USA takes 1.5 round in the circular track, then the displacement is equal to the diameter of the circular track. Because 1 complete round whenever completed, then fine, then this second round whenever she started and she just reach at the opposite end of the diameter. That's why the displacement equal to diameter of the circular track is equal to d. Circumference of the circular track we know from mathematics 2 pi r equal to pi in bracket 2r equal to pi 2r 2 into radius of the circular track. So 2r is equal to diameter of the circular track. So circumference of circular track equal to 2 pi r equal to pi into 2r equal to pi into d. D the diameter of the circular track equal to 200 meter, it is given. Now from this, I need to find out the diameter of the circular track. So the diameter of the circular track is d equal to 200 divided by pi equal to 200 divided by pi, 22 by 7 equal to 1400 divided by 7 equal to 63.69 meter. So this is the displacement of USA whenever she completes 1.5 round in that circular track, whose circumference is 200 meter. Let us see the third question. A ball is there. A ball is thrown in vertically upward direction by Nikki. Nikki is standing on the ground. She is playing with the ball and she is throwing the ball in vertically upward direction. The ball rises up to a height of 10 meter from her hand and comes back to her hand under the action of gravity. Now the question is, what is the total distance covered by the ball and displacement of the ball? You see this picture, Nikki is standing, throwing the ball vertically upward, and the ball is moving down under the action of gravity. The force of gravity there, it is pulling the ball vertically downward direction, it comes back to the hand of Nikki. So total distance in upward direction 10 meter, downward direction 10 meter, total distance must be 10 meter plus 10 meter equal to 20 meter. What is the displacement? Same concept. Displacement equal to 0. How it would be 0? Because the initial position of the object, here the object is the ball, and the final position of the object is the ball. Initial position is the Nikki hand and final position is also Nikki hand. Ball is returning back to the Nikki hand. Since initial position coincides with the final position, so displacement of course will be 0. Well, see this question. An athlete Balbir runs a distance of 10 km towards south, then runs 12 km towards east. So what is the distance travel and displacement of ball bear? These are beautiful questions. So the direction has been shown in this picture: north, south, east, west. Ball bear started from the reference point O and went 10 km in the south direction. So it is mentioned in this picture 10 km, OP equal to 10 km. After traveling a distance 10 km, that is the distance OP, then ball bear turns towards east and covers a distance 12 km in the east direction. So PQ equal to 12 km. So here you need to calculate the distance and displacement of ball bear. So total distance travelled. What is the total distance travelled? Total distance travelled equal to OP, in its first distance OP, second distance is PQ. Total distance travelled is equal to OP plus PQ equal to 10 km plus 12 km equal to 22 km. Well, so this is the distance. Then what about the displacement? We know displacement is the shortest path length between the initial position to the final position. So here the magnitude of displacement is OQ. See, POPQ is a right angle triangle and OQ is a hypotenuse, and the hypotenuse OQ equal to OP square root of OP square plus PQ square. 10 km square plus 12 km square root equal to square root of 244 equal to 15.6 km. So this is the displacement of the athlete. Now you see the fifth question. An athlete completes a circular track of diameter 200 meter with a continuous run in 40 seconds. That means she completes one round of 200 meter diameter circular track in 40 seconds. So what will be the distance covered and displacement of the athlete at the end of the 2 minutes 20 seconds? Now time is given. Time is 2 minutes 20 seconds. You need to find out the distance and displacement in this situation. So if you convert 2 minutes 20 seconds into second, 1 minute, we know 1 minute is equal to 60 seconds. So 2 minutes 20 seconds equal to 60 into 2 equal to 120 seconds plus 20 seconds equal to 140 seconds. Number of rounds athlete completes in 40 seconds equal to 1. That means in 40 seconds the athlete completes one round. The number of rounds athlete completes in 140 seconds equal to 140 divided by 40 equal to 3.5 equal to 3.5. That means the athlete completes 3.5 rounds in that time, that is 140 seconds. Diameter of the circular track given equal to 200 meter equal to D. Distance covered equal to, so 3.5 rounds the athlete completed. That's why the circumference of that circular track equal to 2 pi r. 2 pi r into 3.5 equal to pi into D, because D equal to 2r. Therefore 2 pi r into 3.5 equal to pi D into 3.5 equal to 200 pi, because D equal to 200, that's a 200 pi into 3.5 equal to 200 into pi. The value of pi is 3.14 into 3.5. So that value is equal to, you please calculate that value with your notebook. Then after studying these learning points, what we have exactly learned today? Let us summarize. At first, we learned that an object is said to be at rest if it does not change its position as time passes with reference to a fixed observer or reference point. Then we have studied that an object is said to be in motion if it changes its position as time passes with reference to a fixed observer. Then we have studied rest and motion are relative. Then if an object moves in a straight line path, then it is said to be in linear motion. If an object moves in a circular path, then it is said to be in circular motion. If an object rotates in a fixed axis, then it is said to be in rotational motion. If an object vibrates in back and forth motion, then it is said to be in vibrational motion. Then distance is the actual path length travelled by an object. Then displacement is the shortest distance travelled by an object from its initial position to the final position. Then distance can be greater than or equal to its displacement. Then distance is a scalar quantity and displacement is a vector quantity. So how do you like this chapter? Is it okay? No? Well, I hope so. You must be enjoying this particular chapter and these concepts. Thank you so much.